Hello students, how are you? I think you are well. Now on behalf of Aptdemy, today I shall discuss two problems on mathematical induction. Now the whole chapter has been given in our videography e-learning platform. So those who have already registered, they have no problem. And those who have not yet registered, they were registered within 31st July and they will get a concession. Now, here is another one facility is that you may discuss with the professors on offline or online classes. Now, I, Professor Dr. Gurudakta, will start two problems on mathematical induction. The first problem is that using principle of mathematical induction, prove that 1 plus 5 plus 9 up to 4n minus 3 equals to n into twice n minus 1 for all natural numbers n. So, to work out this problem, first we have to know that what is our mathematical induction. So, first we discuss it. The principle of mathematical induction is, suppose we have a statement Pn. We have a statement Pn. First, we have to show that the statement is true for. First, we have to show that the statement is true for n equals to true for n equals to 1. We have to show it. We have to show that the statement is true for n equals to 1. Then suppose that the statement is true for n equals to m, where m is the positive integer, where m is the positive integer. You have to suppose it. From this, you will show that the statement is true for n equals to m plus 1. So supposing that Pm is true, supposing that Pm is true, you have to show that this is true. Supposing this is true, you have to show that this is true. So the statement is true for all natural numbers or positive integers n. So what is the principle of induction, mathematical induction? First, the statement, you have to show that the statement is true for n equals to 1. Next, you have to suppose that the statement is true for n equal to m, a positive integer. From this, you have to show that the statement is true for the next integer n equal to m plus 1. So it is true for all natural numbers n. Now, come to the problem. Using the principle of mathematical induction, prove that 1 plus 5 plus 9 up to 4n minus 3 equals to n into twice n minus 1 for all natural numbers n. So first we show that we'll take the statement as Pn. So what is the statement Pn? So Pn is our statement that 1 plus 5 plus 9 up to, let us suppose that the statement Pn is our equals to n into twice n minus 1. Pn is the statement 1 plus 5 plus 9 up to 4n minus 3 equal to n into twice n minus 1. So just now I told you what is the mathematical induction. First you have to show that the statement is true for n equals to 1. So if n equals to 1, then what is our P1? For P1, left hand side, equals to 1. What is the right hand side? What n equals to 1? Then this side is our 1 into 2 minus 1. That is our 1. So the left hand side equal to right hand side. So we can write that P1 is true. P1 is true. Next, we have to suppose that, so let us assume that Pm is true. That is, the statement is true. Assume the statement is true. The statement is true for n equals to m. Statement is true for, what is the statement? Statement is this. So what you are given? Pm is equal to, put n equal to m, 1 plus 5 plus 9, these are 2, 4m minus 3, 4m minus 3 equals to m into twice m minus 1. So from this, you have to show that the statement is true for the next integer m plus 1. So m plus 1, what is our Pm plus 1? Pm plus 1 is our 1 plus 5 plus 9, these are 2, 4m minus 3 plus 4 into m plus 1, 4 into m plus 1 minus 3. So for this, up to 1, 5 plus 5 up to this, we can write this as m into twice m minus 1. As because already we have assumed that the statement is true for n equals to m, so you are given this. Up to this, we can write m into twice m plus 1 plus m minus 1. Next, plus 4m plus 1. So what we get? 2m squared minus m plus 3m plus 1. So if we factorize it, what we get? M plus 1 into 12 plus 1. So this term we can write m plus 1 2 into m plus 1 minus 1. So look here. What is the statement Pn? Pn is the statement 1 plus 5 up to 4n minus 3, right side is our n into twice n minus 1. So on the right hand side, if you put n equals to m plus 1, what do you get? M plus 1 into 2 into m plus 1 minus 1. So supposing that the statement is true for n equals to m, we have shown that Pm plus 2 is also true. So by the principle of mathematical induction, from this you can write Pm plus 1, Pm plus 1 is true. So supposing that Pm is true, we have shown that Pm plus 1 is also true. So by the principle of mathematical induction, we can say that the given statement is true for all natural numbers n. So principle of mathematical induction is that first you have to show in a problem, you have to show that the statement is true for n equals to 1. Next, supposing that the statement is true for n equals to m, where n is any natural number or a positive integer, what do you say? Next, supposing this, you have to show that the statement is true for n equals to m plus 1 for next index. Therefore, from this, if it is true, then you will say that statement is true for all natural numbers n. Now we come to the next problem. The next problem, using principle of mathematical induction, 1 square plus 2 square plus 6 square up to n square greater than n cube by 3 for all natural numbers small n belongs to capital N. So first you write, let us write in let the given statement, let the given statement let let the given statement be Pn. So what is our Pn? So Pn is the statement 1 square plus 2 square plus 3 square up to n square equals to, greater than n cube by 3. What was the principle of mathematical induction? First, the statement, you have to show that for this statement, you have to show that P1 is true. What is our P1? For P1, left hand side equals to 1. What about right hand side? One third. So as 1 is greater than 1/3, therefore you can say P1 is true. Next, we suppose that the statement is true for n equals to m. Suppose Pm is true for any natural number where m is a positive integer. From this, you have to show that Pm plus 1 is true. Therefore, you are given Pm means 1 square plus 2 square plus 3 square up to m square is greater than m cube by 3. What is the Pm plus 1? Now, Pm plus 1 square plus 2 square up to m square plus m plus 1 square. We know that Pm is 2, that is, this part is greater than m cube by 3. So we can write this is greater than m cube by 3 plus m plus 1 whole square. So what do you get? Take common 1 by 3 m cube plus 3 into m plus 1 whole square. this is equal to, simplify it, 1/3 m cube plus 3 into m square plus 6m this is equal to 1/3 into m plus 1 whole cube plus 3m plus 2. So what do you get? Pm plus 1, this is greater than, that is 1 square plus 2 square up to m plus 1 square is greater than, therefore we can write 1 square plus 2 square up to m plus 1 whole square. This is greater than 1/3 m plus 1 whole cube. Therefore, Pm plus 1 is true. Therefore, you can write Pm plus 1 is true. So supposing that Pm is true, we have shown that Pm plus 1 is true. So it is true for, therefore, it is true for all small n natural number. This belongs to capital N. So for this problem, what we have done? First, you have to show that the given statement is true for n equals to 1. So put n equals to 1 on the left hand side. We have got, this is our 1, and what is our right hand side? This is our 1/3. As 1 greater than 1/3, so we can write P1 is true. Principle of mathematical induction says, supposing that the given relation is true for n equals to m varying is in positive integer. So we have taken that Pm is true varying is the positive integer. That's why we are given 1 square plus 2 square up to m square. This is greater than m cubed by 3. From this, you have to show that Pm plus 1 is true. Now, what is the Pm plus 1? The summation up to m plus 1 whole square. So we know that this part is greater than m cubed by 3. So we can write this is greater than m cubed by 3 plus m plus 1 whole square. Now we simplify it first. Simplify it. Then this we can write as m plus 1 whole cube plus m plus 2. Therefore, you can write 1 square plus 2 square up to m plus 1 whole square greater than 1 by 3 into m plus 1 whole cube. Therefore, Pm plus 1 is true. So supposing that Pm is true, we have shown that Pm plus 1 is true. Therefore, it is true for all natural numbers n. So this is about the second problem. So for the principle of mathematical induction, again I am telling you, first you show that P1 is true. Next, suppose that it is true for n equal to m. For the next index, we show that Pm plus 1 is true. So it is true for all natural numbers n. Thank you.